Hello. So today we want to discuss about creation of Min-Heap and performing the heap operation in it. So we will write a C program which will implement a heap and will perform the heap operations. So here the heap are two types, max heap and the Min-Heap. Now we will construct a Min-Heap, that is by inserting nodes into it, and the insertion one operation that we will perform on heap, and another operation is replacement. In one of my previous videos I discussed about the replacement operation onto max heap, and the operation replacement was done only for the root node. But in this lecture we will see how we can write a C code to do replacement operation for any node in the heap. Not only root node, but it can be any node in the heap. If we want to replace it by some other new node, then how this can be done using C program, that we will discuss. So that is number 2. Number 3 is that we will discuss how to delete a node from a Min-Heap. In one of my previous lecture, I discussed about the deletion operation only for the root node, and it was for a max heap. But in today's we will discuss the operation deletion for any node in the heap, and the heap is Min-Heap. So we will learn now how to write a C program for heap implementation and for doing the operations on a heap. So for that, before that I will tell one thing, that how this heap, when we will want to do the heap operation, that means we want to create heap by inserting node into it, or if we want to delete any node from it, or we want to replace any node from a heap. So for this operation the heap should be represented in one form so that we can do the operation on it. So how this representation of heap can be done. Heap can be represented in two ways, either by using arrays or either by using linked list. In future lectures, I will discuss about how to represent a heap using linked list. But for this lecture, we will represent a heap in a one-dimensional array. So when a heap is represented as a one-dimensional array, the accessing of any element, any node in that heap is very easier. But it is better that if the heap size is too large, then it's better to represent it with linked list, but that will be discussed in one of future lectures. Now for this lecture we will concentrate only the one-dimensional array representation of a heap. Now heap is actually a balanced binary tree. But before that I will tell that heap is a binary tree. So it can have either one or two children, not more than two. So it be binary tree, that is the property or characteristics of a binary tree, that a node can have only one or two children, not more than two. Now if this binary tree satisfies some other properties as well, So then it is renamed as some different data structure. For example, if the root node of any subtree in the heap, if suppose there is a binary tree and the root node for any subtree of that tree is like that, it is greater than all of its children, it has higher value or than all of its children, then we call it a max. On the contrary to it, or to the opposite to it, if the root node is that it has the lowest value than all of its children, then we will call it a min-heap. So that means the root node of a heap, if it is a min-heap, always contain the lowest value among all the elements in that heap. So when a binary tree is like that the root node or the parent node of any subtree is such that it has less value than all of its children, then we call it a min-heap. Now, when this heap is represented as an one-dimensional array, then tree means there is parent and child relationship. So how when it is heap is represented as one-dimensional array, so how can we find the parent-child relationship? Suppose a child is at index 1, I in the array. So its parent node will be at index I by 2. Or suppose a parent node is at index I. So its left child will be at index 2 twice of I, and the right child will be at index twice I plus 1. So in this way we can find out if any node, then what can be its parent nodes and what can be the children nodes of it, that we can find out by this calculation. Now our question is, we will create a min-heap. For that, what I will do, all the elements in the heap are given in a one-dimensional array. So by arranging this array elements in such a way so that the parent-child relationship will satisfy the properties of a heap. If elements can be arranged in such a way within that one-dimensional array, then we call it that it's a heap. Now, for this purpose, when we want to create a heap, a number of elements are given.